Okay, this is going to turn out to be part 4. 4 parts to this lesson, alright? So this is the 4th and final part. I said this on after the 3rd part. I thought that would be the final part, but it just got too long, so I had to split it up. So this is the 4th and final part of our lesson on graphing rational functions, but we're not actually graphing. We are just finding the asymptotes. Alright, we're talking about vertical asymptotes, horizontal asymptotes, slant asymptotes, and holes that are in the graph. Alright, let's take a look at number 9. Alright, we have 2 more problems. I'm just going to make them fit in this video regardless. Let's factor some stuff, man. Looking at these 4 terms, I feel some grouping coming on. Alright, you guys know what I'm even talking about right now? Have you forgotten how we do things? I just lost my cursor. Alright, technical difficulties. Please stand by. Alright, let's do a little grouping here with the numerator to factor this thing down. Grouping. Remember this? GCF here. So that's like I've got x squared, and then I'm going to have x plus 4 left behind there. And here I have a common factor of -6. Alright, it's got to be -6 because of that minus sign. But if I pull out that -6, okay, and then that's going to leave behind x plus 4 again. Why plus 4 when there's clearly minus signs everywhere? Remember, if I do the distributive property, it has to get me back to where I started from. If I do -6 times x, sure enough, -6x. If I do -6 times +4, that would give me -24 like I want. If I had a -4 right here, a negative times a negative would make a +24, and that would be totally wrong. So it has to be like this, which is a good thing for grouping because these parentheses have to be the same. So now that I see that these are the same, I can take this x plus 4 and pull it out to the front like this. Alright, and that's going to leave behind the x squared and the -6. So x squared minus 6. Okay, so there we just factored the numerator. So I'm just going to copy this. So this numerator is going to become, alright, x plus 4 times x squared minus 6. Alright, great. Now let's factor the denominator. The denominator, x squared can only factor as x times x. Okay, the denominator, I'm looking at this 4, so it could be 2 times 2, but I'm thinking 4 times 1 because I got an eye on the 5. Okay, now remember, inner plus outer has to equal middle. Inner, I've got 4x. Outer, I've got 1x. I'm trying to get 5x. I can do it if both of these are positive. That will make positive 5x. That means both of these would have to be positive. Will that give me a positive 4? Sure, positive times a positive is a positive. So this is now factored correctly. Okay, now everything is all factored up so I can really see what I'm dealing with. So normally I would look at the denominator for my vertical asymptotes. And normally I'd be thinking, oh look, this is going to give me x equals -4. And this is going to give me x equals -1. These are my vertical asymptotes. Yay. Whoa, wait, whoa. Okay, this is a vertical asymptote over here. But this one is going to give me a hole. Alright, there's going to be a hole at -4, not a vertical asymptote. What's the difference? Because these cancel out. And when the vertical asymptote factor cancels out, it gives you a hole, not an asymptote. So there will be a hole at -4. Okay, so let's record what we have so far. Okay, so look, I've got a vertical asymptote, x equals negative 1. Okay, I've got a hole forming, and so far I know that it is negative 4 comma something. I still need the y value of it. How do I get the y value of that hole? Well, I put this part into my TI-30XS multiview, and I check out the x value and see what the y value is that goes with it. So x squared minus 6 over x plus 1. So what do I say? X squared minus 6 over x plus 1. Okay, and I want to know what's going on at negative 4. So I'll just tell it to start at negative 4. Okay, at negative 4, the y value is negative 10 over 3. Just leave it like that for now. So negative 10 over 3. Okay, so we have a hole at negative 4 comma negative 10 over 3. So we have vertical asymptote, we have a hole. Now what about the horizontal asymptote or slant asymptote? Well, there will be no horizontal asymptote because the top degree is higher. But because the top degree is exactly 1 higher, that tells me that there will be a slant asymptote. So I'm going to go ahead and get ready for that. How do I find the slant asymptote? Long division is how I find it. Okay, do I have room over here? I'll do it over here. So I've got setting up my long division, people. Okay, I've got x squared plus 5x plus 4. Alright, so I've got x squared plus 5x plus 4. And I'm dividing into x to the third power plus 4x squared minus 6x minus 24. Okay, long division's the only way to do this. X squared times what will give me x to the third power? X. Alright, then take it and do the distributive property with it. Whoops, I kind of missed. Whatever, you get it. X times x squared is x to the third power. X times 5x is 5x squared. X times 4 is 4x. Alright, we subtract by changing the sign. So this will become minus, this will become minus, everything becomes minus. So these cancel out. This is going to make what? Negative 1x squared. You know, normally I don't put the 1, but it's not the end of the problem yet. These make negative 10x, and I bring down my minus 24, because why not? Okay, and I do one more level. One more time I turn around and I ask myself, x squared times what will give me negative 1x squared? Well, guess what? It's going to be negative 1. And then I do the distributive property. Okay, negative 1 times x squared is negative 1x squared. Negative 1 times 5x is negative 5x. Negative 1 times 4 is negative 4. And I will subtract by changing the sign. So this will become plus, plus, and plus. So these cancel out, but this is going to give me negative 5x. And this is going to give me negative 20. Alright, but this is just a remainder. What matters is the quotient up here, x minus 1. Because that is going to give me my slant asymptote. Alright, keep your eyes on that x minus 1. And slide over here. Whoops, I messed that up a little bit. Alright, that x minus 1 will give us a slant asymptote of y equals x minus 1. So that is the complete answer to number 9. We have vertical asymptote at x equals -1 because of that. But because these cancel, that gave us a hole at -4. To find the y value, we plugged this part into the calculator and checked it out. And then the slant asymptote, once again, happens when the top degree is 1 greater, and you find it by doing division. And whatever the quotient is, ignore the remainder. That is your slant asymptote. Alright, this video is already quite long, but I do not feel like making a separate video for number 10. So, I am going to keep going, regardless of how long this is. So, number 10. However, I think I'm going to skip this to the next page. Shall I? Number 10. Look at that denominator. Alright, once again, grouping is looking pretty good. GCF from these two. I see 9x squared as a GCF. So I got 9x squared. That's going to leave behind x plus 5, right? Because 9 times 5 is 45. Meanwhile, over here, you know, if you want, you can look at this as a -1 that has to come out. So I'm going to pull out this -1. Now if I do that, what will be left behind is x plus 5. Again, why plus 5? Because if I did the distributive property, if I did -1 times x, that's -1x. -1 times +5 is -5, so it makes sense. Okay, but since these x plus 5s are the same, I can pull x plus 5 out front. That's going to leave behind the purple stuff. So that's going to leave behind 9x squared minus 1. Wait a minute. Are you seeing what I'm seeing? What am I seeing? That's right. Difference of 2 squares. This can totally factor further. How will it factor further? 3x plus 1 times 3x minus 1. Okay, this factors further. So, you know what? We have now factored this all the way down. We are just that incredibly smart. Okay, nothing can stop us. So, let's just copy all this goodness over. So, we are in the factoring business. So, the denominator has become x plus 5 times 3x plus 1 times 3x minus 1. Alright, there's your denominator. Now, the numerator. Hopefully, the numerator will factor just as easily. Alright, 2x squared can only factor as 2x times x. 5 is a prime number, so it can only factor as 5 times 1. Alright, or 1 times 5. Alright, I'm going to try that because I see that like maybe this will make x plus 5 and cancel with that. I'm always thinking about stuff like that. Anyway, inner plus outer has to equal the middle. You know this, man. Inner, we have 1x. Outer, okay, we have 10x. We're trying to get this middle of positive 11x. Can I get a positive 11 out of a 10x and a 1x? Well, yeah, it's already given me positive 11. Just leave it as positive and positive. Is that going to give me positive 5? Sure. Positive times positive is positive 5. So that is how you factor the numerator. Okay. Now, normally I'd be looking at this and going, oh my goodness, do I really have 3 vertical asymptotes? I've never seen 3 vertical asymptotes before. Well, you know what? We still haven't seen 3 vertical asymptotes. Alright? Why not? Because as we simplify, these would cancel out. And if they cancel out, it's still an illegal value. -5 is still an illegal value, but it's not going to be an asymptote. It's just going to be a hole. Okay? So let's go ahead and start our little list of asymptotes and holes. Okay, so vertical asymptotes. Alright, if I set these equal to 0, you know, like the 3x plus 1 and the 3x minus 1. If I set those equal to 0, this is going to give me 3x equals -1 and 3x equals +1. Dividing by 3 on both sides will give me x equals -1/3 and x equals +1/3. I'm dividing by 3. These are vertical asymptotes. So x equals -1/3. X equals +1/3. Okay, vertical asymptotes. We'll go ahead and put a box around that. Okay, now this x equals -5, that's not going to be an asymptote because it canceled out, but it will be a hole. There will be a hole at, and I've got the x value so far. You know, if I take this x plus 5 and set that equal to 0, obviously that's going to give me x equals -5. Alright, not a vertical asymptote, but it is the x value of a hole. How will I find the y value of that hole? I will find the y value by putting the rest of this into my TI-30. So the 2x plus 1 over brat. Okay, so I'm going to put that in my calculator. Okay, let me just make sure. 3x plus 1, 3x minus 1, 2x plus 1. Okay, I've typed it in. Now I want to know what's happening at an x value of -5. So I'm just going to tell it to start at -5. Okay, that's -9 over 224. Interesting. I'm going to need a bigger set of parentheses. So that's -9 over 224. Okay, so there's my hole. Alright, so I got a vertical asymptote and a hole. Now, am I going to have a horizontal asymptote or a slant asymptote? Or neither? Well, the horizontal asymptote is all about the degree. This is that situation where the top degree is less than the bottom degree. So what does that tell you? That tells you that y equals 0 is the horizontal asymptote. So there is a horizontal asymptote, and it is y equals 0. Alright, so there's no slant asymptote. Alright, remember, the slant asymptote happens if the top degree is 1 higher. Alright, if the bottom degree is higher, then it's a horizontal asymptote of y equals 0. And that is it. That was problem number 10. This video is like 31 minutes long, so that's getting kind of long. So I'm glad we're done. Alright guys, this is going to take some practice. You know, all this new information. Next thing you know, we got a test. Alright, there's a lot of information. So please do not copy off me. I should have been saying that all throughout this whole video, but some of you guys, well, frankly, some of you are not listening to this video because you just went straight to the answer key and copied down the answers. Alright, you know, like if this is a homework assignment for you. Now you're going to get your homework points, but when the test comes, you're going to fail. And then what you look like, okay? So please make sure, you know, go back and redo these problems by yourself if you've been sort of doing them along with me. Alright guys, good luck out there in the world. My daughter has green hair, but I still love her. You know what? I like the hair. It's cool. I like it. I like it. So I shouldn't say I love her despite her green hair. You know, I love her more because she's like got that kind of free spirit that causes her to do the green hair. You know, like I dig that about her. She's not a conformist. So there you go. Power to the people.